Let us discuss half-range cosine series or sine series. There are many practical applications in which we will have to reduce Fourier series expansion for a given function in terms of sine functions alone or in terms of cosine functions alone. This is because Fourier series expansion involving sine functions or cosine functions alone finds its application while we try to analyze temperature distribution along a rod or in a plane sheet. Also, this can be used to describe transverse vibrations of a string when both ends of the string are kept fixed or both ends of the string are moving in periodic pattern. First, let us discuss how we can frame half-range cosine series. Suppose we have a function f of x defined in the interval 0, L and we wish to make half-range cosine series, that is, our Fourier series must contain only cosine series or cosine functions and not sine functions. For this purpose, we will extend f of x to the interval minus L to L. That is, f of x, which was defined only for the interval 0, L, will be extended to the interval minus L to L such that the new function defined is an even function, or it satisfies the property of even function. When we do this, we have Bn equals 0 for all n. Suppose capital F of x is the new function which is obtained by extending small f of x to the interval minus L to L. Then we will have capital F of x equals f of x itself for the range 0 to L, and we have extended it in the interval minus L to L such that this function will satisfy even functions property. Therefore, we will have this branch will be symmetric to this branch, that is, we will have in the range minus L to 0 f of x, capital F of x equals f of small x. This newly defined function capital F of x is an even function and it coincides with the already defined function small f of x in the range x belongs to 0, L. Also, you can see that the graph of capital F of x is symmetric with respect to y-axis, which ensures that the function capital F of x is even function. Since we have Fourier coefficients Bn equals 0, we will have Fourier series expansion given by capital F of x equals a0 by 2 plus summation n ranges from 1 to infinity an cos pi n x by L, and this will coincide with f of x for the range x belongs to 0, L. While we define half-range cosine series, we will have a0 equals 1 by L integral minus L to L f of x dx. Since we have defined f of x as an even function, we can replace integral minus L to L f of x dx as 2 times integral 0 to L f of x dx. Thus, we will get this expression for Fourier coefficient a0. Similarly, we have an equals 1 by L integral minus L to L f of x cos pi n x by L into dx. Since f of x is even function and cos pi n x by L is also an even function, and since product of two even function will again be an even function, we will have this function which appears inside the integral will be even function, and hence we can replace integral minus L to L f of x cos pi n x by L into dx as 2 times integral 0 to L f of x cos pi n x by L into dx. Since we have f of x is even function and sine function is odd, product of even and odd function will be odd function, and hence this integral will become 0. Since Bn equals 0 for all n, we have Fourier series expansion for f of x involving only cosine terms given by this expression.